So for today's video, we are going to discuss the chapter 9 transport layer. The role of the transport layer is to make the data from the application layer to become um, a segment, so that it will it um, can easily send um, data if it's divided into segments. And application delivering data to them. And next, transport layer responsibilities is tracking individual conversations. Transport layer track each individual conversation flowing between source application and the destination application separately. So if I send to the to the to the other host, and the host sends the message to me, the transport layer will track each messages from both the client devices. Then the segmentation, the transport layer divides data into segments that easier to manage and transport. For example, in this figure, these are the segments that we're able to that the transport layer will send. Then Now, these are the segments for instant messaging, for email, multiple web pages, online video chatting, and streaming video. Transport layer ensures that even the multiple applications running on the device, all applications receive the correct data. Kahit napakarami ng gumagamit sa device, it can manage to send the data to a multiple application running on a device. Next is a conversation multiplexing. Let's wait for the figure. Conversation multiplexing is just like um, sending some types of data across the network as one complete communication stream can consume all the available bandwidth. So on this one, segmentation allows conversation multiplexing. Multiple application can use network at the same time. So that's what conversation multiplexing do. It enables the application to use network to use multiple application on a network from the same time, like what's what's on the figure. Then segmentation facilitates data transport by the lower network layers. Error checking can be performed on the data in the segments, to check if the segment was changed during the transmission. So there's also an error checking on the segments to know that if that segment was changed during the process. And next, transport layer reliability. So this is the transport layer. Transport layer has two protocols: the transmission control protocol and the user datagram protocol. TCP is more reliable. TCP is more reliable than UDP, but UDP has more faster transmission than TCP, because TCP checks every detail. Not every detail, but it checks very detailed the segments, so that it avoids dropping segments, or and also uh, on the next sections, we will talk about TCP and UDP. Next is TCP. TCP transport is an analogous to sending packages that are tracked from the source to destination if a shipping order broken up into several. Okay, let's play the figure. So the user send an FTP. So the first three out of segments are there, and okay. So what happened here? What happened here is the user sent the first three message. The user sent an FTP file or just FTP. It sends it over a network, and then after the FTP server receive the segments that sent by the user, uh, the FTP server send an acknowledgement to let the user know that it, the message was already received by the FTP server. So because of that, we can say that the TCP is a very reliable transport because it will ensure the user that the server or other host computer will res, had received the messages, and also uh, the messages that will that will the user send that we're going to send to the server is sequenced, and also it's ordered on how the user sent the message. That's how the server or devices will receive the message. The next is UDP, or user datagram protocol. Okay, let's play. It's like the first. Okay, so okay, the user datagram protocol. It's a type of protocol which like an IP address that uses best effort, which means it's unreliable. Why I can say it's unreliable? Because it's good for its fast transmission, but the thing is it doesn't send an acknowledgement if the server or another computer received the messages from the user. And also the sequence of the message that was sent can be interchanged during the process. And that's all. Next, the right transport layer protocol for the right application. So as we can see, a UDP require so it belongs on when using a telephone like that, but TCP is for email and HTTP for a reliable reliable output. Or for example, wait, UDP require protocol properties fast, low overhead, does not require acknowledgement, does not resend lost data, and different data as it arrives. So this too um, has that is fitted to that requirement for the UDP protocol. UDP is good because it's fast and it's low overhead, but the thing is it does not require acknowledgement. So anyone will not able to, and also it's a connectionless. Either there's a connection between two hosts or not, it will able to send the data. And the TCP needs to establish a good connection so that it will be more reliable, and it acknowledge the data that it sends and resend the lost data if some if the lost data will if for example six segments was sent, and the receiver received only four segments. So If the acknowledgement returned to the sender, it will tell that there are two loss segments on that data. So whether the computer will send the two data that lost on the process, then deliver data and sequence order. Next, TCP features. TCP features is a session, establishing a session, same order delivery, reliable delivery, and flow control. I think I already said the earlier the a while ago the establishing a session that ensures application are ready to receive data or send a data, and same order delivery that the segment assembled to proper order on how the segment comes out from the host computer. That's how it will be received by its destination or the receiver. Then reliable delivery because means lost segments are resent so that the data received will complete, like what I've said a while ago. And a flow control ensures that the receiver able to process the data received. Then next, the TCP header. TCP is a stateful protocol. Stateful protocol is a protocol that keeps track of the state of communication session. So TCP is aware on how the session is was established or what are on the session. That is a stateful protocol. Then the TCP segment is encapsulating the application layer data. Its source port is 16 bits and destination port is 16 bits. Source also this is it. And the sequence number, it is 32-bit. Also the acknowledgement number, and the header length is 4. Uh, reserve is 6. Control bit is 6, and window size 16. Then the it has a checksum 16 and urgent 16, and that's all for the TCP segment header. Then let's proceed. UDP features. UDP features is data is constructed in the order that is received. And the segments lost are not resent, like unlike the TCP that it will resent if it know that there's a data loss in the process. The no session establishment, it means connectionless, does not inform the sender about resource availability. And next, UDP header. Because as we can see, UDP headers of fast transmission than TCP, so it has also a very small UDP header. UDP header is a stateless protocol, meaning neither the client nor the server is obligated to keep track of the state of the communication session. If reliability is required when using UDP as the transport protocol, it must handle the application. Then the UDP also has a source port and destination port, and just a length and a checksum. Then let's proceed. And the UDP header is just an 8 bytes on size. The next, multiple separate conversation. Okay, multiple separate conversation was going through a different port. Um, Unlike port addressing, electronic mail is to it will go to 110, HTML page to 80, and internet chat to 531. TCP and UDP manage these multiple simultaneously conversation by using header fields that can uniquely identify these applications. These unique identifiers are the port numbers. These are the unique identifiers this so that it can manage multiple simultaneous conversation. The transport layer must be able to separate and manage multiple conversation with different transport requirements needs. Okay, then next, port numbers. Port numbers has a source port and a destination port. So this source port number is associated with originating application on the local host. So the source port number is from the source of the application or source host and associated with the destination application and the remote network. So a source port number is dynamically generated by the sending device to identify a conversation between two devices. These processes allow multiple conversations, okay, and the destination port, the client pastes destination port number to segment to tell the destination server what service is being requested. Shown in the figure, for example, so the transport application port data to 110, application port and data to 80, and the protocols is POP3 and HTTP and IM. The data for different applications directly directed to correct application. Okay, next. Socket pairs. Okay, socket pairs source destination ports placed with a segment. Then the socket on the web is I think it's hmm. Okay, what is socket? The combination of the source IP address and source port number of the destination IP address and destination port number is known as a socket. So it is a combination of the IP address and destination port. A client socket might look like this: the 1099 representing the source port number. 1099, hmm, 1099, representing okay, this source address. The source port represent this, and this will represent this. Okay, that called a socket, and together combined for socket pair. Socket enabled multiple processes running on a client distinguish themselves. Okay, then port number groups. Well-known ports is 0 to 1023, and the registered port is 1024 to 49151. Then the private and or dynamic ports are for 49152 to 65532. Then this is the port number for um for different protocols. It's all most of them all are well-known port numbers. Okay, let's proceed. The netstat command. Unexplained TCP connections can pose a major security threats that can indicate someone connected to the local host. So TCP connection also sometimes it's necessary to know which active TCP connections are open and running on the network host. That's the most the is an important network utility that can be used to verify those connections. Okay, netstat will let us know if the to verify the connections between the network. By default, netstat command will attempt to resolve IP addresses to domain names and port numbers while no application. The dash "n" option can be used to display IP address. So the dash "n" will able to display the IP address, and the netstat command will attempt to resolve IP address domain names to domain names. So TCP servers processes. So so in this figure, as we can see, the client sending TCP request. Okay, the clients are sending TCP requests. So the destination port is 80 and the SMTP port is 25. So it will accept the request Then source port is 49,152 and 51,152. Then this so the response destination port is on their source port, and the source port now is the destination port of these two clients. Okay, let's proceed. TCP connection establishment. Okay, on this figure, we are able to see how the connection established on a TCP connection. So, on first, the host A will send SYN to the host B, and the host B will reserve the SYN. And that is, the host B will going to send a SYN and an acknowledgement that the host B was already has already received the SYN, and it will be received by host A, and the host A will going to receive an acknowledgement that it already received the acknowledgement by the host B. So it is the it is how TCP establish a connection. The next, TCP session termination. So on this section, we were able to know how the TCP will terminate the establishment connection. Then first is the host A will send. Oh, but for this called a three-way handshake. Three-way handshake, and this is a what's it called? And later, um, the host A will going to send a fin to host B, and the host B will receive it, and it will acknowledge the host A, and also it will send a fin to the host A, and the host A will send an acknowledgement, and that's how the TCP connection establishment, and that's how the TCP connection termination session terminated. Okay, let's continue. TCP reliability order. So, and the data is divided into segments. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, and it will be sent. Different segments may take different routes. So it possibly some segments will go here and some segments will go here until it hanggang sa dumating sila sa target host. Then the TCP reorders the segments to the originate order from 1, 2, 6, 5, 4, 3 to 1, 2, 3, 4, 5, 6. Okay. Then TCP flow control, TCP window size. So window sends window 10,000, send window 10,000 during three-way handshake. The size of 10,000 MSS 1460. Sequence number is 1460 bytes. Receive 1 to 1460. Then sequence number 1461. It will go into send 1004. Okay. Then receive an acknowledgement from host B. Send window 12,920. Then sequence number 2000. The window size determines the number of bytes that can be sent before expecting an acknowledgement. An acknowledgement number is the number of the next expected byte. Okay. Then next. Yan. TCP flow control, congestion avoidance. I'm not going to the acknowledgement I expect from PCB, so I will reduce the number of bytes I send before getting the acknowledgement. Acknowledgement numbers are for the next expected byte and not for a segment. The segment numbers are simplified illustration and purposes. The UDP is a simple protocol that provides the basic transport layer function. It has much lower overhead than TCP because it's not connection oriented and does not offer the sophisticated retransmission sequencing and flow control mechanism that provides reliability. So as we can see here, there are no UDP does not establish a proper connection. There are no proper connection on our network. Then UDP provides low overhead data transport because it has small datagram header and no network management traffic. And UDP datagram reassembly. Uh, if you send a data is divided into datagrams, so 1 to 6. After if it's sent to the to the target host, it might able out it might be out of order or some of the segment was dropped during the process. Server process request, next, UDP client processes. Um, so it's like on the TCP. There's different port numbers and applications that uses UDP. Oh, wait. Applications that uses TCP are HTTP, FTP, SMTP, and Telnet. They use TCP because they need a reliable and strong established connection between two hosts. And this is the application that uses UDP, DHCP, DNS, SNMP, TFTP, VoIP or VoIP or Voice over IP, and IPTP was is are using UDP. Like features can tolerate some data loss, simple request and reply application. Okay. So that's all for chapter 9 transport layer. I hope you understand something and I hope you learned something from me and thank you for watching this and peace out.